My name is Kun Tran. This is Amanda from Street Home. So we're going to talk about the inspiration and problem statement.
So our project is inspired by those technology that were created that's aimed towards assisting people with disability. And the area we choose to tackle on is closing the gap between hearing community and the deaf community. So our design goals are Internet of Things, basically sending data from the glove to your phone wirelessly, and two-handed translation, that's basically using both of your hands doing sign language, and algorithm that can translate American Sign Language into English because the sentence structures are different. And here are the extra design goals that we wanted to get done, but we weren't able to implement. So text-to-speech function, basically sounding out the word that was translated. And wirelessly basically means we don't have this cable connected to the machine. You can just walk freely. And display screen, instead of having display on your phone, maybe we'll have a little screen on your chest to display the word that you translated.
Oh, so these are the hardware that we use. So we have the Arduino board, flex sensor, the gyroscope, soldering board, so on. So these, we're going to talk about it in detail in the next few slides.
Okay, so we wanted to start out with one-handed translation first because two-handed would be too complicated. So we start with flex sensors, which are essentially resistors. So which change resistance based on how much your finger is being bent. And with some math, we made it so it does the angle of the finger. So we do 0 to 360 on simplified things. So we rather than like 5,000 resistance to 10K resistance, we have 0 to 360. And we also have gyroscope, which it measures the orientation of your hand. So it will be at the X, Y, Z axis, and it's between values -1 to 1. So if it's up, Z facing like this, Z will be at 1, and then facing down, Z will be -1, for example. We also have an accelerometer, so it measures the acceleration and the direction at which you're going. So if I move in the X axis, it will show how much the speed of it, and it will also be an X, Y, Z axis as well. So that will help determine like movement, sign language movements. And then the brains of the entire thing will be the Arduino Uno, which is basically where we connect all the hardware to, and then we upload our code to that. And then to continue, so we ran into some problems in terms of the analog ports. So we had an analog expansion board, which expands the 6 ports on the Arduino to 24. So since we have 10 flex sensors, 6 is not enough. And also the next one is also the 12-key capacitive touch sensors. So we ran into problems when it comes to the alphabet. So if I do V, right, you can't really tell the difference between U or R. So we have copper touch sensors. So when your fingers are touching, you could know if the fingers are touching based on that. So the next one. And then next one will be the two-handed translation. So once we get one-handed translation down, we go to two-handed translation. And then, so basically we add 5 additional flex sensors and 1 more gyroscope and accelerometer to the left hand. Yeah. And then there will be the I2C multiplexer, which just expands because we ran into the issue of only having 1 SCL port and 1 SDA port. And so we expanded it, we used a multiplexer to expand it from 2 each.
So we talked about the sentence and the phrase. So apparently American Sign Language and American Sign Language and English are different for grammarly. So for sign language, what you're trying to do is just try to get your point across. So if you say ball, I hit, it just means I hit the ball. But that is in English, it's say I hit the ball. But in sign language, you're just gonna sign the ball, and then you say I, and then you say hit. And so we don't have a particle. So if you want to say someone is something, you just say I engineer. It's me, I am engineer in English. But in sign language, it's just I am engineer. So what I try to do is that I use a micro SD card reader, and what it does is that if you want to store a bunch of text file, and these shall be text file, or differently, so I'm going to have a subject text file, a verb text file, and then an adjective text file, or like a question text file. and then I just have a bunch of words in it. And so when I do a sign, I'm just gonna compare that to each of the text file. If they found it, then I set it as a subject, and then so on. And the next one is verb, and then all I need to do is just reorder the subject, and then just put the particles in between them, and you make the sentence. But the thing is, that's what we think, but when we do it, the Arduino board memory was so small that when we try to do the IoT, there's not enough memory for it to run. So when we try to send this, all the sentences to internet and download it to our phone, there's a traffic jam. So the data just froze and they're not sending. So I have to take out the micro SD card and I have to do it a different way. So we just use a bunch of string array instead. And it works, so yeah.
So for IoT, due to the school's internet policy, we were not able to directly utilize the school's Wi-Fi. So at first we tried to use the Raspberry Pi as a router for school's internet, but then that didn't work. And we also tried other methods, but then through tons of research, we found that we need our own server to upload the data we finished translating, to upload the data to server and then pull it out from our phone. And we found the app that's called Blink. Basically, we're borrowing their server, uploading our translation, and then we'll pull it out from our phone.
So we're going to show you some, this is a current problem. So yeah, so the problem is the sign language sentences, they still not finished. Technically, we only have a few that is working. We still haven't get the verb to work. But yeah, but we got the question to work and the sentence, the normal sentence to work, the article ones. And then the implement text-to-speech function, yeah, so we was gonna save like our voice into a WAV file and then just play that word when we do that certain word. So, but we didn't have time for that.
Also, like the micro SD card problem,
Yeah.
where they keep storing the value, the recordings in the SD
card.
card value, but we
not
can't use the SD.
enough memory. We was gonna buy a bigger board so it have more memory, but it just not enough time to order from Amazon right now. so I couldn't toss off it. And then we have the Raspberry Pi. So yeah, we have the Raspberry Pi, but then yeah, we didn't have time to make a wireless. We connect to power bank everything, but
Yeah,
it
so
just doesn't work with the
yeah, we don't have like the script to
Yeah,
run,
to
like,
run
the
it
code
without
automatically,
the,
so we
without
actually
the-
still need the module.
Yeah, so there's no point.
Yeah.
So that is, and we have the demo test. Oh, for this one, this just a data test. I can just run it.
So these are the videos. In case our live demo doesn't work, this is the backup. We can't set up right now. So you can
Better
just-
to run with,
So we also set an initialization point because everybody's hands are different. So you want to put your hands like this so you can calibrate your hands.
Yeah, so
and
you-
then when the code
So they see like
falls zero.
which angle is 0 degree. If you do this it will count as 0 degree. But I want everything to be straight for it to count 0 degree. So I have to initialize it in the beginning when I run the code.
So this is essentially how we do the translation stuff. So we have it print out a bunch of different codes,
That's
and so it reads the gyroscope, like which position it is. If I make a movement, it will also show like the speed and which axis it was going in. And then we also have flex sensors. So when we bend the flex sensors, like the angles will change.
So he bend the finger right now. Every angle are like very
Yeah.
degree
So-
wise, it's like very high.
Yeah, pretty much everything is bent except my thumbs.
But if he like flat it out and everything or reduced down to low degree.
Yeah, so it'll be very close to zero.
Yeah. And
Which
we
is
just
nice.
work with that for the sign. And we also have the gyroscope. So let's say if he phase it everything upward, I can read that so the z is almost equal 1 here. Same with this one. So both of them equal 1 and these are 0. If we phase it to the left, or both of them to the left. So it's something like that. You can see the x is going to the 1 because we're facing x positive direction.
Yeah.
So
And
that's how.
also,
if
we also
you-
have the touch sensors too, if you want to show that.
But that's not-
Yeah, I'll just show it like which touch sensor is being touched or not.
Yeah.
So it just shows up.
And
Okay.
so with the next one we have is, let's say, the full hole. We have too many files, just super disgusting. Okay. So this one is the one where we make it work with how the IoT. I think the second code is kind of long.
Yeah, it's like 20 pages of code.
Yeah. All right, got it.
So if I go with like A or just
Yeah, so
A,
printing
like
A,
or
B,
conquering B.
right? So
And
that's
then I
B.
could do like phrases like thank
Thank
you,
you,
I could do
hello,
hello, I could do the name,
and so now we're gonna demonstrate on our team.
Yeah, so this one is just gonna print infinitely, but once we have it on the phone, it'll just print out like individual words.
Okay, so IoT, the difference between IoT and Bluetooth is that Bluetooth only work with one device, but for IoT you can work with multiple devices. So everybody that connect to my phone or whoever scan the code,
Well, whoever has the app.
have the app, will be able to link to the same things. So let's say, so we can have multiple phones connecting. Oh, this is just a previous test. They're gonna get clear when you run the script. So it should be the same. Okay, should be good.
Yeah, so if I'm putting A, it'll say A on the current word, right? So, but it also prints out subject in the translated sentence. So if I do like me, and I do engineer, for example, it'll put the particle, and it'll be engineer is me, or I do engineer.
Because usually when sign language, when you sign it, the first word is going to be the object
no,
that you
say,
talk
I am
about,
engineer.
and then the second word will be your subject. So if I say engineer me, which means I am the engineer.
So also if I could do the phrase like
Yeah.
A, or am me engineer, or
And
like,
also, if you do engineer and you do me and you do question mark, it would be am I an engineer?
yeah. So if I do example, okay, wait. So if I do engineer, and do you, right? And then
It should
it'll
say
create you are engineer,
You are an
right?
engineer.
And then if
But
I do
add a
question
question mark,
it'll say are you engineer?
yeah. So that's how it works. That's how it works so far.
Yeah.
Always gonna have verb too, but
Yeah, we didn't get the
micro, the micro card,
Yeah,
the buttons, so we didn't have time.
Yeah,
to
so we
fix it.
did, like he did the algorithm, but
Yeah, it's
the
like-
micro SD card like killed all the memory, so you had to like redo the entire thing.
Because when I run Arduino, the memory was because the SD card library alone is like 20% of the Arduino memory, so it just shoot up to 102% and it couldn't run. They say too much memory, so that they can't.
And we tried cutting the code as much as possible, and we go on guide to like 99 or something. Yeah, but it still was.
I had to do a lot of class by reference from my C, which I thought I never gonna use.
Yeah. I'll talk about the budget and cost. So our budget was $1,000, but if you see it, like the total was like around 480 cents. So basically, most of the costs went to the flex sensors because we had 10 of them, and then we also had to do the 2 gyroscopes, 2 accelerometers, and then like a lot of this hardware we didn't even end up using, like the Wi-Fi module. Well, we didn't end up using the Raspberry Pi kit. We didn't really use much. And then like the micro SD card we didn't use much. And then also the accessories and tools, like it's a lot of cost, but we could actually reuse a lot of that. It's more like crimping tools, soldering tools, that kind of stuff. So that's why it's expensive. So it's like if we minus all of that cost, it's like
Yeah, 340 something.
yeah, somewhere around that.
It's pretty cheap. Yeah.
So we were under budget by a lot.
So the result, we got 2 hand-to work, translate letters, word, and common phrases, thank you, hi, hello, so on. Mobile application work, IoT, and basic grammar. So got some of it to work, so that's good. Future work, will be improvement on the algorithm, so it's understand better and work more smoothly. Also, some of the sign that we do, we have to do it manually, which is take too long. for each of the signs. So like engineer, you have to measure the angle for each of them and do an if statement. If the angle is right and the accelerometer is right and there's no and there's a movement on the right and there's a movement on the left, then it's sad.
Yeah,
But
and
that is
also
just
the
too much
movement,
work.
the gyroscope changes because if I move, the gyroscope changes. So you also have to do more like we try doing delays. And then so if there's enough time where it reads the gyroscope, like it changes.
So what I think of the future work is that we're gonna have like 2 AI, so that if we do the motion over and over again, I guess it's gonna read that better. And it's even better if we have like a whole list, like because dictionary is like too many words. So if you only have a micro SD card, that's not gonna feel like every single word out there is in the United States. You know, you have to like put it on a server, so it's better just to take the word from the server and just put it down. So that's what we should do. And the Raspberry Pi, it just start up, so we got it to work with the Raspberry Pi on the screen, but without the screen I cannot see login, so we have to log in and not username. I cannot do it automatically.
So we wanted to have a script to run automatically.
Every time you turn on the Raspberry Pi, and that should just replace our laptop and run quietly.
Yeah, because the Raspberry Pi, we have a power bank that actually connects to Raspberry Pi. It's
Yeah.
actually powerful enough to run it by itself.
So, any questions?
Questions for the team?